is Michael LePage, and this is the second part in my series of videos about space settlement called Settling the Incliptic. This part is about using 3D printing for aquaponics in space, and how we might use that to create a wheel garden on the International Space Station. 3D printing is really coming in leaps and bounds over the last few years, and these guys, made in space, are taking a 3D printer to the International Space Station. So I'm really excited to see how they go with that. I've been thinking about this process, 3D printing, and how we might use that to prototype for larger space structures, fixed radius assemblies. So here's something I've been doing in Google SketchUp, and this is an object that could be printed, and it tessellates with itself in 3D space. So here, to show that, I've got 4 of them, and they all fit together like so. And if you put an angle on the vertical edges, then you create a 3D object that can be printed in a modular fashion that tessellates it with itself in 3D space to create a ring. So here's the first concept I ever did, and there are 36 modules there. Here's another concept I did when I was initially scaling it up to human size. I thought, how might we do this? It's rotationally symmetrical. It has, so it can turn 180 degrees and fit into itself. It has spots for cables, which I'll explain in the next slide. But the important thing is that if it's rotationally symmetrical, then that internal space can be closed off so that each time 2 modules are printed out, they enclose a space. And so for a ring that has 72 modules, there are 36 enclosed spaces and a corridor that goes around the entire length. So, how do we assemble these? I've just done a little animation here. There are 2 different modules, the peach coloured and the pink coloured, are actually the same thing but flipped 180 degrees with respect to each other. And so we can assemble those in the same way you might thread beads onto a necklace. Each time you print out another module, you put it on the cable. You print out another module, put it on the cable. And you keep going until you produce a ring-like structure. And I'm after that because that will have elements under both compression and tension, and that should be strong like the rim of a barrel. So, how to use that? Well, aquaponics is something that I've become really interested in the last few years, and it's the combination of aquaculture, which is fish farming, and hydroponics, which is soil-free plant growth. And it's cyclical because it effectively replicates the nitrogen cycle. So you've got nitrogen from fish effluent, so you've got the fish piss out ammonia, the ammonia gets converted by bacteria to nitrate fertilizer for the plants in turn filter the water for the fish. So all you have to input to that is fish food, and the output is edible plants and fish. So I'm going to show you a little rig that I've set up myself. These things can be quite small, so this is an ordinary 18-litre fish tank. I've got a 12-litre pot here, and I'll show the video I took. So the water is pumped into the pot, the water goes into the plants filter the water for the fish. And I'm only using little goldfish here, but if I was using larger fish, I'd be able to eat those as well later on. Why focus on aquaponics when I'm talking about space station building? Fair question. And my answer is that, well, if you look at land use on Earth, the majority of it is actually for some form of primary production, so farming of some kind. And I put it to everyone that this will stay exactly the same in space. No matter how many people are actually involved in the farming of it, the majority of the use of space in space stations will be to do with some kind of food production. And so aquaponics is good because it's a very efficient use of space. It replicates the nitrogen cycle, it's relatively labour free, And I realized that, well, there's quite a lot of water and various other materials used in this. This is actually a pretty good starting point for how you would design modular ring assemblies, ring-shaped space stations. Aquaponics is good because it lends itself to modularity. The primary mechanical components of aquaponics are not complicated and can be 3D printed, so pumps, fish tanks, plant boxes, even the soil substitute, which is these expanded clay bowls, could probably be printed in some fashion by 3D printers. So for the remainder of the video, I want to show how I use 3D printing to make an aquaponics rig that could be implemented on the International Space Station. So here we are back in Google SketchUp. Got a module which has a space for water in it. It's got the two holes for cables which bind the entire ring together, the nubs that allow each of the modules to lock into the adjacent modules, and that fits in, or rather I've got a grow bed type arrangement that fits in to the lower water containing modules. So to see how that fits in together, the gaps in the grow bed actually lock the two water containing modules together, and so if you can see the little nubs where they fall in together, nubs where the cables attach to the main axis, and so here's how they look when they're all interlocked together. And so the way this looks as a ring is something which is 1.8 meters in diameter and about the size of a person as they would be standing upright in the International Space Station, or floating upright. So it has 72 tank copies, 36 insert copies, and so that's a total volume of about 20 litres, and it spins at about 34 revs per minute to achieve 1 Earth gravity. Now, one idea would be to use a small species like krill as the fish component, and also that the pumps would pump the water along the ring from grow bed to fish tank to grow bed to fish tank, so it's all effectively one space. Aquaponics is great because it gives utility to the prototypes. As with all large endeavours, it's important to start with baby steps, and making aquaponics a unifying concept means that we can build small, then medium, then large, and all of these prototypes will be functional. Part 3 and 4 will show how this concept scales up to space station size dimensions.